Okay, more set theory now. Set theory, so far we've talked about lots of different symbols. Let's just go through a few of the symbols again, just before we talk about Venn diagrams. So you can have sets of things. So you could have like a set A, and that could be the numbers, I don't know, 3, 4, 5, 6, 7. You can have a set B, which is, let's say it's 5, 6, 10, 30, and 52, right? And you could also have another set, let's do another one, which is 4 and 7. Now there's relationships between the two different sets. Definitely one of the ones that stood out yesterday that people weren't sure about was subset. If you have a subset, it's a symbol that looks like this. It's a little bit like less than, and it's meant to be a little bit longer than an actual capital C. But here, C has 4 and 7 in, and there's a 4 and 7 in A, so you can say that C is a subset of A. Okay, and it means if you were drawing a Venn diagram of these two, you would have A, which is a great big set with loads of things in it, but C is inside it. So there's 4 and 7 here, but you also have 3, 5, and 6 in A. So that's A there and that's C there. So a subset, this symbol, is something which is completely inside another set. There's also the other symbols. Let's just go through all of those symbols. Right? We had this one. This means is a member of, so that means 3 is in the set A. We had the intersection, so A intersect B. That's basically the same as saying something that's in A and B. So the intersection would be something that's in both sets. Something in there. The union is something that's in one or the other. So it can be anywhere. You can shade in anywhere in A or anywhere in B. So this is, like we said yesterday, not yesterday, when was it? Tuesday? And this one was and. So the intersection is just that middle bit. That's that one. And the union is everything. So this one is, it has to be in A and B. This one, it can be anywhere. It can be in A or in B. So you can place stuff anywhere. And if you're shading that diagram in, this is what this diagram looks like, and that's what that diagram looks like. And because I know that the IMaths exercises had some Venn diagrams, I want to go through a few different possibilities. So I've made some interactive Venn diagrams. Well, when I say interactive, they're just bits of paper. Let's just start off with one set. Let's say this is our one set, this is set A, right? You've got either an A or you've got outside of A. And this symbol, the little dash afterwards, it just means something that's outside of a set. So if it was set B, you could have B and you could have outside of B. And together, if you have these two, this and this together, and that's all you've got, those two together make the entire universal set. And the universal set is that funny curly E. Now, we can go one step further with this. Let's have two sets instead of just one. Right? So, I've got, this took me minutes of work. Okay. Let's say we've got all of these different parts. I'm going to have set A, these two together will be set A, these two together are going to be set B. Okay, so here I've got my two sets, A and B, and I can work out different parts of it. If I want to talk about the intersection, that would just be that bit there. So that is definitely just A intersect B. And together, if I had this one here, those two together would be A completely. But what if I wanted to just describe this bit? This bit here is sort of A, but without B. And you can talk about how this works. So you've definitely got some of A, but we've sort of got the intersection of A and outside of B. outside of B would be everything that's completely outside of B. So that would also include that bit. So outside of B is everything outside of B. But the intersection of outside of B and inside A is just this bit here. So this is definitely inside A, but also it's outside B. And you could do something similar with this bit. Over here, we've got, this is inside B, but it's outside A. It's those two things combined. So that's that one. So we've got these three together. Now, these three together, all of those three make the union of A and B. That's A union B. And that whole region, if I just flip these over, describes everything that's in A or B. So we've got the union there. And we've also got like interesting things you can do with the bits on the outside. So this is just everything that's outside. Now if I had this, then that would just be everything outside of B, so that would be B dash. If I had it on this side, that would be everything outside of A. But I could just have everything outside of both of these. And you can combine together two things we've done. So this bit which is left over is the union. That's A union B, but we're looking outside of that. So it's A union B dash. This is things which are not in A or B. The bit which is missing here is A union B. We could also have things which are sort of outside the intersection. That would be everything apart from the intersection. That would be like including those two bits, but leaving out the intersection. So that's everything outside of anything that's inside A and B. So it's outside that bit, which was the intersection. That bit has been taken away. Okay, so things can get a little bit complicated, but I think it helps a lot to remember the and or business, because and or helps you to try and describe in words what's happening. You've got the A and B, which is definitely the bit in the middle, and then you've got A union B, which is anything in A or B, which is everything. And then you can start having variations and combinations. You can have things which are outside this region or outside this region. Let's have a look at three sets, because if you have three sets, the same system applies, but you have more possible places. Okay, so now we've got three sets, A, B, and C. We can talk about like just a combination of two different things. So the bit in the middle, so if I just had this bit up here, that's very similar to what we were doing before with two sets. This would be the intersection of A and B. So A intersect B, and you can have this one. That would be the intersection of A and C, and you could have this one. That would be the intersection of B and C. But what about just this bit in the middle? If you've got three sets and you're right in the middle of there, that would be the intersection of all three. And you can combine together all three letters. You could even have the union of all three of them as well. So the union would involve everything in A, or everything in B, or everything in C. If I extend this to the union, I've got all my cardboard cutout bits. One more piece, there we go. That would be the union of all three of them. So that would be A, union B, union C. But then you could even start mixing this together. So what if you had A union B and then the intersection with C? So let's start with the first bit. Let's do the bit in brackets first, using BIDMAS, BODMAS. Let's have a look at A union B. So that's everything in A or B, but we're looking for when is that intersecting C. So which part of this is also in C? And that would be just these three sections here. So we'd have this. So that is like quite a special region there. you can start combining three things together with brackets. And what you do is you look at what's in the brackets first. Let's do another one like that. What do you think would happen if we had, let's say, B intersect C and then union A? Okay, so let's do the bit in brackets first. A intersects C, B intersects C, that's just this bit here, right? But we also want to have the union with A, so it can be this bit, which is just that, A, which is all of A there. We want to know whether something can be here or it can be here. So we've got this section, but we've also got all of these as well. So we'd end up with something like this. It's just one bit sticking out there. So that's got anything which is in B intersects C here, or it can be an A as well, so it can be up here. Now you can have that sort of thing combined with dashes. So let's have a look at something with dashes. Okay, what if we had, I can do the border of it. What if we had A dash intersect B and then intersect C? So A dash intersect B, what does that mean? We want something which is outside of A and inside B. So there's loads of stuff which is outside of A, but the only bits which are outside of A and inside B would be here. Because, oh, and here as well. So this bit here and this bit here. So we're just on the first bit in brackets. You have to do this in stages because it's far too much to do in like all in one go. So this is outside of A and inside B, this bit. Now we also want to know, when does this intersect C? So when does this part, which is the bit in brackets, also end up in C? It's just this bit, so we can take that away. So this bit here is outside of A and inside of B and inside of C. What if we have like a union as well? Let's do, I saw one just like this in the My iMaths exercises. Let's have B dash intersect A union C. So again, it doesn't matter where the brackets are, we do the brackets first. So A union C, it can be inside A or inside C. So we've got loads there. All of A and all of C. Where's the middle bit? Oh, it's in my hand, right. It's that bit, and this bit. Okay, so that's the union of A and C. Anything that's in A and anything that's in C. It can be here or here. But we want to know, when does this overlap with things which are outside of B? So we don't want these bits because they're inside B. We want things which are outside of B. So it's these bits around here. We take that away, and that away. So that's B dash is outside of B, and it's inside the union of A and C. So we did the union first. You do the brackets first, and then afterwards you think about what's happening. Now, there was a crazy one at the end of the My iMaths exercises, and I think you can do this. But this is definitely way crazier than some of the ones we started with. Let's have a look at this one. It's so big I have to write it at the bottom. This is brackets A dash intersect B dash C union B dash intersect A intersect C. So it's ridiculous, but you do one bracket and the other bracket, and we've got a union in between. So we're going to work out what this is, and we're also going to have this bit, and then we're going to see where we can have something here or something here. So this bit here, this is outside of A and inside of B and inside of C. So inside of B and C, it has to be somewhere here, but it has to be outside of A, so it's just this bit. There, that's that one. This one, well, it's pretty much the same, but it's got B dash. So this one has to be outside of B, but inside A and inside C. So inside A and C, that's here, but outside of B is here. So it's just that bit. So let's put that one in. And we just want the union, so we want something that's here, which is that one, or here, which is that one, and that's both of them. And there we go. So you just have to break it down into stages. The regions of the Venn diagram can be described in different ways. So you might be able to describe this same thing in a different way, but if you want to work out what this description is talking about, you have to do the brackets first, work out what's happening inside the brackets, and then combine it with some other things. So right, what I want you to do is to work through the exercises in the book, the MyIMaths exercises. There's loads of videos online about Venn diagram regions, so if this is not enough, you can keep on searching, but I don't want you to give up. I want to see if you can do both of those exercises, get 100% on both of them, and I also want you to do the 2 exercises I set you from the book as well. And eventually you'll get the hang of this. It just takes practice. It takes time, it takes effort, it takes practice. But I believe in you. Bats!